He's a baby. Oh my god.
Hi everyone. Sorry I had to do a virtual lecture today, but we'll go back to normal on Wednesday. Monday is Labor Day, so there's no class.
You need to hold the phone?
Yo. Skew.
Yeah.
Done with your stuff?
Yep. Guess what? I don't know.
You went to the one that opened up on campus today. And I don't know why you did that. I know Matthew said you have to make an appointment. And I know in Lubbock, the appointments for Katie's roommate haven't been for 5 hours. Or Abby couldn't get it till 7 yesterday. I don't know. Oh.
Okay. Before we get started, if you send me an email about the homework, the written one on Blackboard, you can go ahead and still submit that. I opened it up, so if you didn't get a notification from Blackboard saying that you submitted it, then try again. And yeah, it's no problem. It's mostly just to make sure you guys can submit things on Blackboard in case in the future we need to. So this is more just of a trial run and just kind of a free grade I'm giving y'all because it's not really anything that requires much besides just copying down. So if you don't know how to do that, if you're still having problems, let me share my screen and can everyone see Blackboard right now?
Yes.
So just you go to your section and all you have to do is go to homework. Here's where you got it. I have the instructions. You can click that photo and bring it up, and then you just click right here. This is a link, and this is where you put your submission. So you browse computer and you can upload that photo. If you took the photo on your phone and it's not on your computer, just email yourself the photo and save it to your computer that way. So you have until tomorrow at midnight to get it submitted. So try to work out those errors if anyone in this class is still having them. But okay, let's go ahead and get started. Okay, so I'm going to go ahead and mute everyone. I am going to ask you questions just to make sure y'all are paying attention and stuff. So unmute yourself whenever I ask questions, and still participate, please. But that way there's no echoing and everyone can focus. So I'm going to go ahead and do that for you guys. And so let's see. Okay, y'all are all muted. Just again, if you have a question, just please unmute yourself and ask. So let's get started. We finished section P5, and then we're going to do section P6 today, and then we'll also do section 1.1, which I'll have homework on Pearson as well. So let's look at rational expressions. So rational expressions, these are just they're just quotients of two polynomials. So here are some examples. We have x minus 2 over 4, x over x squared minus 1, x squared plus 1 over x squared plus 2x minus 3. So this is just any polynomial. So you can say x squared minus 4 over x squared minus 25. This is just a rational expression as well. So this is important because when you have polynomials,
I just realized what that said.
Anyway, this is important because whenever you have these polynomials, you can't have 0 in your denominator. So we're going to look at that, because if you have 0 in the denominator, it's undefined. So here is whenever we have, let's look at this example. If x was equal to 1, let's plug that in and look at what we would get. 1 over 1 squared minus 1, you get 1 over 1 minus 1, which is 1 over 0. So you get a 0 in the denominator, that's undefined. You can't have that, so just keep in mind, never can have a 0 in denominator. So what we're going to do is we're going to look at, whenever we have polynomials and top and bottom, we're going to look at what x cannot be. So you're going to take this denominator, rewrite it, and set it not equal to 0, and you can solve. So there's two ways we can solve this. We can factor it. Remember, this is that a squared minus b squared method I taught y'all, where you get a minus b, a plus b. So x squared minus 1 is x plus 1, x minus 1. So we're going to take these two and set them not equal to 0. Okay, so that means you can take the first term, we'll separate them and set it not equal to 0, second term, not equal to 0. And then you solve, so subtract 1, and what you do to one side, you do to the other. And then do the other one, plus 1 on one side, plus on the other, so x does not equal 1. So x cannot equal -1 or 1, or if you wanted to just straight away solve it, you can also do, let me add another page. Well, let me just go down here actually. If you had x squared minus 1 does not equal 0, you can also just solve it from here. You can do plus 1, and you get x squared does not equal 1. Take the square root, and you just have to remember, when you take the square root of anything, it's plus or minus 1. So that's another way of solving it. So if you forget that, that's fine. This is why factoring it kind of works out better. Okay, so the next example, what are we going to do? We're just looking for numbers that exclude the domain. So whenever you have fractions, again, you have to worry about denominator. So okay, so it was 9x over x squared plus 3x minus 18. So again, we're going to take our denominator and we're going to set it not equal to 0. Because where it is equal to 0 is where it's undefined. So again, we're going to factor this, and we just find factors of -18 that add to a +3. So we already know that when you have a negative, we went over this in our last class, when you have a negative right here, the only way to get that is a positive times a negative. And we know when we're factoring it, x squared, x times x. Since that leading coefficient is 1, we can do that. So now we're just going to find out what these factors should be. So -18, We're going to look for factors that add to 3. So let's just start and list them out from the beginning. We have 1 and 18, 2 and 9, 3 and 6. So a -3 times a +6 gets you -18, and -3 plus 6 gets you a +3. So that's going to be our factors. So we have x plus 6, x minus 3. And these do not equal 0. So you're just going to take each binomial and set it not equal to 0. Okay? And we're going to solve them. So x plus 6, we're going to subtract 6. So what you do to one side, you do to the other. So x does not equal -6. Add 3, and x does not equal 3. So that is where our expression is undefined when x is -6 and when x is 3. So if I ask you on your test, what numbers are not included in your domain, this is how you would solve this. Okay, so let's look at simplifying rational expressions. So this is important because if you are wanting to look at if I were to ask you that same question, what numbers are not included in your domain, you might be tempted just to solve this denominator and solve it out, and you'll make a mistake because you'll see that sometimes you can cancel out variables, you can cancel out binomials, or that's what simplifying this rational expression will do for you. So let's go ahead and simplify this and see what our domain would be afterwards. So let's factor the top, and you look for factors of 5 that are going to add to 6. The only factors of 5 are 1 and 5. We have a positive here and a positive here. So 1 plus 5 is 6. So that's all you have to do. X plus 1, x plus 5. That is the factor top. And then x squared minus 25. Again, this is in that form. A squared minus b squared. So you guys got to remember this. This is equal to a plus b, a minus b. So it's going to show up a lot. So this just becomes x minus 5, x plus 5. And then you can tell that the x plus 5's cancel, right? Because that's the same as saying 2x over 2, our 2's cancel. So the x plus 5's cancel. So you're left with x plus 1 over x plus minus 5. And then if I were to ask you what is the domain of this function, you would have to figure out what number to exclude from domain, and you would just take your denominator and set it not equal to 0. You'd solve for x, so you'd add 5, and you would get x does not equal 5. And that would be your answer for that question. So again, always simplify first because your answer is dependent on that. Multiplying rational expressions. Does someone have a question? No? Okay. So multiplying rational expressions. Before you multiply, this is just for you. Like, you can multiply them without simplifying first, but that's going to create more work for you in the long run. So before you start multiplying everything out, go ahead and simplify. So x minus 7, that's as simple as it goes. X minus 1, that's as simple. Okay, so what about x squared minus 1? Can someone tell me what I can simplify that to?
X plus 1, x minus 1.
Exactly. So this one is x plus 1, x minus 1. What about down here, 3x minus 21? Is there anything I can do?
You can make it, take 3 on the outside, and it will be 3 parentheses x equal, x minus 7.
Perfect. So exactly. So now let's just go ahead and rewrite everything. Let's rewrite this first one, x minus 7 over x minus 1. We still have multiplication, and it's times x plus 1, x minus 1, all over 3x minus 7. Okay, so then you see, you can put this in parentheses just in case maybe you don't see it, because like I've been keep telling you guys, these are binomials, and I call them family, right? And so you can't split them up. These are together. So maybe you put those parentheses so that you can see that more easily. And you'll see that the x minus 7 cancels. X minus 1, that cancels. And you can do that when you're multiplying across from two polynomials, rational expressions, I guess. But if you don't see it, go ahead and multiply it completely out, and you'll see x minus 7 times x plus 1 times x minus 1. And I'm not going to distribute yet because I want to simplify before. Because if you distribute all this out, you're just creating more work for yourself. So always keep things factored until the very last minute. So again, these cancel out, x minus 7 and x minus 7, and then x minus 1 and x minus 1. So you're left with x plus 1 over 3. And so that works out nicely. There's nothing for us to distribute it out or no terms to combine, so we're good. And that's your final answer. Okay. Dividing rational expressions. Let's take a look at that. So whenever, yeah, of course, sorry.
Thank you, got it.
Okay, you're welcome. So dividing rational expressions, just keep in mind when you're dividing, so we have a fraction divided by a fraction. So when you do that, you rewrite your first fraction. You change your sign to multiplication and you flip it, right? So I would do that first, just in case I don't know, so you don't forget. Maybe when you're factoring and stuff, you thought you already flipped it and you'll change it to multiplication, you'll get your answer wrong. So I would go ahead and flip it and do all I guess that little more simpler procedure first. So once you've done that, now we're gonna factor each term. So we have x squared minus 2x plus 1. So let's factor that. Can anyone tell me what it would be or what you would do?
Got an x.
Yeah, so we'll have x times x gets us our x squared, and then we have a positive here. So we're looking for factors of 1 that add to -2. So we're gonna have a negative and a negative, and then factors of 1 are what?
1 and 1.
Yeah, so it's not too bad. And so you can condense this. You could write this as x minus 1 squared, but I would wait because maybe some of them will cancel out. So let's just leave it how it is. And then at the end, if we still have the twice repeating, we'll condense it. So in the denominator, what can we factor out?
Can't you factor out the x?
Yes. So we're left with x squared plus 1. Can I factor x squared plus 1?
Yes.
You would think so, but you can't. It's prime, because just remember, a squared minus b squared, yes, you could have factored. So if it was x squared minus 1, yes. And then x squared plus 1, whenever it's plus, or a squared plus b squared, this is prime, so you can't factor. That's okay. Lots of people are going to want to do that. So just make sure that y'all remember that when you have a minus, yes, you can keep going. When you have a plus, you can't. It's going to stop there, and you can't go any further. So that one we're good. We're not going to keep going. Let's go to the next one. So what about, can you factor anything out from the top on this next one?
3.
Perfect. And you're left with x squared plus 1. And again, since it's plus, we can't. If we're minus, we could keep going. At the denominator here, same thing. We're going to just set it up. Our leading coefficient is 1, so we just have x and x. We have a -2 here and a positive here. So the only way to get a negative is having a positive and a negative. So factors of -2, that adds a positive 1. So we know the only factors of -2 are 1 and 2, and we want our 1 to be negative because -1 plus 2 gets us a positive 1. So then you just fill that in. So 2 goes here, -1 goes here. Okay, so what cancels out?
The x minus 1.
What else?
X squared plus 1.
Yes. So we are left with 3 times x minus 1 over x times x plus 2. Okay, and then if you distribute this out, because sometimes I think it's necessary because you can combine like terms and maybe factor again. In this case, it won't really simplify it much more, but let's go ahead and do it. 3 times x gets you 3x, and 3 times -1 gets you -3, and then x times x is x squared, x times 2 is 2x. So that's your final answer. Okay. So we're finding the least common denominator in this next one.
I had a question about the last one.
Yeah, of course.
Well, so like if you left it as 3 times x minus 1 over x times x plus 2, would that be the correct answer, or do you have to distribute?
You can either one. I'll accept either one. I guess if maybe the problem specifically states like no parentheses or something on your homework, I wouldn't do that on a test. But if it says something like that, then go ahead and distribute. But they're both the same. I would take both.
Oh, okay. Thank you.
Yeah, if you get it, we'll look at one where if you keep going, we can see if it goes further. The point of that was just to see like maybe if we had something that's gonna factor. This one wouldn't really matter, but maybe if we had like I don't have an example at the top of my head, I'll have to write one. But if we had something where you could further factor it after distributing to cancel out the denominator, then maybe. But again, like I said, this is a fine answer. So even if that did happen, what I'm trying to say in not a very good way, if that did happen, it wouldn't mind. I would still take this answer.
Okay.
So finding the least common denominator. So just remember, like if we had 1/4 and 3, I don't know, like 3/2. What is our least common denominator? 4, right? Just look at factors of 4. So we had 4, 8, 12, 2, 4. Oh, so the first factor that they both have in common is your LCD. Or example, let's look at like 1/3 and 2/3. That's a little, or not 2/3, but I don't know, 2/9 or something. You would say 3, 6, 9. Or actually, here's a better one. Something that's not a multiple of each other. We can say 2/3 and 1/3 and 1/2. So factors of 3, we have 3, 6, 9, and then factors of 2, 2, 4, 6. So 6 is our first common factor. So our least common denominator would be 6, right? So this is essentially that same thing. And if we see another way that we got 6 was 3 times 2, right? 3 times 2 can get you 6 as well. So that's the same method that's going on whenever you have binomials or trinomials or just any polynomial. So if we have x plus 1 and x minus 1, the only way to get the same LCD is to multiply them by each other. Oops, I saw my cat. So LCD is x plus 1, x minus 1. Okay, so you're going to look at the first fraction and you have x plus 1 and you're going to look at it and you're going to say, okay, well, what am I missing? Because sometimes you might have an even bigger LCD than that, and you'll just look at it and you'll say, what am I missing? Well, I have x plus 1. I need x minus 1. So we're going to multiply this denominator by x minus 1, and what you do to the bottom, you have to do the top. So your new rational expression becomes 3x minus 1 over x plus 1, x minus 1. Okay, and then the next one, we have 5 over x minus 1. So you're going to do the same thing. You look at your denominator, see what you're missing. We don't have x plus 1. We do have x minus 1. So we're going to multiply by x plus 1. And what you do at the bottom, you do the top. So you get 5 times x plus 1. And your denominator is x minus 1, x plus 1. And so now we see that we have the same denominator here, and we could add those fractions, subtract them. That's the point of finding common denominator. But right here, the goal was just to find it, so we did. So now we can add or subtract them. Let's look at an example where we actually do go further with the problem and add and subtract them. So to do that, let's factor our denominators first. So what is this one? Does anyone know what this one is just by looking at it? What do? We say, what terms go right here?
Wouldn't it be -2 and a +1?
Yes.
Yeah.
or no,
Yeah, reverse.
backwards. Yeah, that's good. X minus 1 plus 2, but yes, same factors. And then what about this next one? X squared minus 1. We all know that one, right? X plus 1, X minus 1. So make sure y'all guys know that one, because like I said, this is that a squared minus b squared method. Okay, so now what is our LCD? We want to write down let's write down everything that this one has. X minus 1. So X minus 1's here and it's right here. So we just have to write it once. X minus 1. X plus 2 is here. It's not over here, so we're going to need to write it. And then X plus 1 is right there. So now that's going to be our LCD, and we want to make sure we want to get that the LCD for both of them. So we have X plus 3 over X minus 1, X plus 2, and you're going to look at it and you're going to see what you're missing. So you have X minus 1, okay? You have X plus 2, okay? You don't have X plus 1, so we're going to multiply it by X plus 1. What you do to the bottom, you have to do to the top, so that way it remains equivalent. And then let's look at our next one. We have 2 over X plus 1, X minus 1. So again, we have X plus 1, right? We have X minus 1. We don't have an X plus 2, so we're going to multiply by X plus 2. Well, you do the bottom, you do the top. Okay, so let's go ahead and simplify this, or I guess not simplify really, but multiply it out. So we have X plus 3 times X plus 1 all over X minus 1, X plus 2, X plus 1, plus 2 times X plus 2 over X plus 1, X minus 1, X plus 2. All right, now that our denominators are the same, we can add them, right? Because that's like saying 1/4 plus 3/4. Now that they're the same, you could say 1 plus 3 is 4 over 4. So all this becomes is X plus 3 times X plus 1 plus 2 times X plus 2 all over the denominator, and you just have to write that one time. X minus 1, X plus 2, X plus 1. Oh, I added it on the wrong page. Okay, so it cut off a little bit, so let me just rewrite this down here. So again, it's X plus 3 times X plus 1 plus 2 times X plus 2 all over X minus 1, X plus 2, X plus 1. Okay, and then for some reason it does this, and when I erase it, it doesn't do it, but if I do that, it does. So okay, so now this kind of answers that question that one student had earlier about, do we need to distribute it out? Sometimes you might, so let's go ahead and distribute the top. Let's leave the bottom alone for now, and let's distribute the top and see what happens. So X times X gets you X squared plus X plus 3X plus 1, and then plus 2X, and then 2 times 2 plus 4. Okay, all over that denominator. So let's see if we get any like terms. So X squared, there's only one, so we're just going to write it once. We have an X, a 3X, and a 2X, so you have 4X, 6X, and then 1, and did I mess up somewhere? I think I did, sorry. I think I did, sorry. X times X gets you X squared, X times 1 gets you X, 3 times X gets you 3X, and 3 times 1 gets you 3, not 1. So plus 3. So yeah, that's another thing, just, you know, we're all human, we make lots of mistakes, so I make them all the time too if I go too fast, or so just make sure to always take your time. So that's so anyway, 3 plus 4 gets you 7. So we're going to look for factors of 7 that add to 6. Rewrite that denominator. I'm not going to distribute it out just in case the top factors out. We'll see if it does. Factors of 7 that add to 6. So the only factors of 7 are 1 and 7. Let's see. If you add them together, -1 times a -7 gets, if you add them together, it's -8. +1 times a +7 gets you positive and adds to 8. So we see that we can't actually factor the top, right? Not nicely or anyway. So we can't factor it, so you'd actually just leave it how it is, and this is your answer. So in this case, you could leave it this way, but this looks a little nicer because you've gotten rid of some of those parentheses, so I think that's good. Okay. That's it. It won't erase. There we go. So simplifying a complex rational expression. So this isn't too bad. Just think about if I gave you 1 plus 1/4, what would you do? How would you add those?
You would make 1 into 4/4.
Right. So what she did was she got the same denominator, right? So another way of getting that 4/4 is, well, we know that 1 is equal to 1 divided by 1, right? Because if we divide by ourselves, we still are equal to ourselves, right? Or not really ourselves, but numbers. If we divide by a number by itself, it's still that number. So 1 divided by 1 is still 1. If you want the denominator to be 4, you multiply by 4. So 1 times 4 is 4, and 1 times 4 is 4. So this is the same thing. If we have 1 plus 1 over x, we know we want our denominator to be x. And we know we can write that 1 as 1 over 1. So if we multiply by x over x, then you get x over x. So we're going to do that for this top and this bottom. So we're going to rewrite 1 as x over x plus 1 over x, and the denominator as x over x minus 1 over x. So let's just go ahead and add them. Now that we have like denominators, we can add. So we get x plus 1 all over x divided by x minus 1, or let's keep it in, I guess, fraction term. Go over this, divided by x minus 1 over x. So now it still looks kind of messy, so the best way to go about this is write it out, I guess, like horizontally, like how I was starting to. So rewrite this first fraction, x plus 1 over x. Instead of dividing it out like that, go ahead and write divided by, and then x minus 1 over x. And so we know that when we're dividing two fractions, you leave the first one alone, you change your sign of multiplication, and you flip the second. So we flip that second. And now we see that what canceled out? Anything?
The x.
Yes. So you have x plus 1 over x minus 1. And that would be your answer. Okay. All right, cool. So we are done with section p.6. We're going to do section 1.1 now. Does anyone have any questions before I move on? No? Okay. Sorry if you guys can hear my dog. She's annoying sometimes. Where was that one? There we go. So this is chapter 1 is about equations and inequalities, and then section 1.1 we're going to look at graphs and graphing utilities. So we need to understand the graph in ordered pairs first. So an ordered pair is just going to be x and y. So sorry, my dog, she's being bad over there. So anyway, an ordered pair means you have the x in the x position and a y in the y. So anyway, let's look at how this works on a graph. I'm gonna have to zoom out a little bit. Can everyone still see that okay? I think you can. Okay, So let's look at what graphs look like. So the vertical one is the y-axis. And then the horizontal is the x-axis. Okay, and technically you can have arrows on all of these. All this means is that the graph keeps going on and on and on until infinity. I like to usually just draw it at the top and the right to represent the positive, because on the y-axis, the top is positive, and the bottom is negative. And then on the x-axis, the left is negative and the right is positive. Okay, so in other words, we'll have, you know, positive 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, 3, so forth. And they go on forever. So anyway, this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, so when you have ordered pairs, so remember our ordered pairs look like this, X and Y. So when you have an ordered pair in quadrant 1, you're going to have a positive X and a positive Y. In quadrant 2, it's on the negative X-axis, so you're going to have a negative X and then a positive Y. In quadrant 3, you'll have a negative X and a negative Y. And then in quadrant 4, negative X, oh, sorry, no, you will have a positive X, right? Because we're at the positive X-axis, and a negative Y. Okay, so let's look at that. Let's label these together. So go ahead and unmute yourselves. For this first one, we have negative X, positive Y. So which quadrant would we be in?
Quadrant 2.
Quadrant 2, negative X, positive Y, perfect. All right, what about positive X, negative Y? What quadrant?
4.
What about this one? We have positive X, and then right here we are on the Y-axis, or yeah, on the Y-axis. So it would be like right here, right? So this one's kind of a trick question. You're not really in a quadrant. Instead, you're on a, I think it's called quadrantal, but let's just call it X-axis. I don't remember if that's what it's actually called. So let's just call it X-axis. Oh, and then we'll get to there actually. -5 and -3, which quadrant would you be in?
3.
And then 0, 4. So where would you be here?
The y-axis.
Yes. And then 0, 0.
The
This
origin.
is, yeah, this is called your origin, if y'all didn't know, the origin. Okay, so let's go ahead and plot these together. I'm going to do it by colors just so we can make sure we all can understand the graph. So again, and so this might help you if you already labeled the quadrants. We'll just write that 1, 2, 3, 4. So it just goes counterclockwise. So anyway, let's do that and graph them, and you can just double check -3 and 5. So we already said it's in quadrant 2. So all you're going to do when you're labeling points is you're going to run, and then you jump, right? So we're going to run to -3, and then we're going to jump up to 5, and that is going to be point A. Okay, and then for B, we go to quadrant 4. We're going to run to 2, and we're going to jump down to -4. Okay, the x-axis, we're going to be on the 5, 0 for C. So we'll be on the x-axis, and we're going to run to 5, and we're already at 0 on the y, so it's right there on the x-axis, C. D, we go to -5, -3, so we're going to run to -5 right here, and then we're going to jump down to -3. Okay, and then our y-axis is 0, 4, or I mean point E is on the y-axis, so 0, 4, and that's E. Okay, Okay, and then our last one, our origin is 0, 0, right here. S. Okay, so we've labeled some points. Now that we know how to do that, we can now start graphing equations. So let's take a look at this equation right here. When you see x squared, just know that your equation is going to be in the shape of a parabola, which we'll get into that. But that's just what that x squared stands for. So let's get started. So whenever you're graphing just by points, it's best to do some negative values and always do a 0 value and some positives. So let's do -3, -2, -1, 0, 1, 2, 3. Okay, so if we plug in a -3 into y, then we have 4, and just remember that our y is 4 minus x squared. So if we plug in -3, then we would have 4 minus -3 squared, which becomes 4 minus 9, which is what? -5. Okay, and what about -2? You would have 4 minus -2 squared. So you get 4 minus 4, which is 0. Let's do -1. So 4 minus -1 squared is 4 minus 1, which is 3. And then 0, we'll do 4 minus 0 squared. So you get 4 minus 0, which is 4. And you just keep going. Now we're at our positives. 4 minus 1 squared. So you get 4 minus 1, which is 3. 2, we have 4 minus 2 squared, which is 4 minus 4, which is 0. And our last one, 4 minus 3 squared gets you 4 minus 9, which is -5. So with the parabola, you'll see that for your x value, if you have a -3 and this corresponding +3, these two, you have the same y value, right? And so that's what happens with the parabola, because the parabola looks like this, or it looks like this. And so in our case, this negative is going to tell us that it's going to be upside down, but we'll get more into that. You don't have to know that right now. We're just going to plot it by points and you'll see it. So your ordered pair, let's just write it. What's the ordered pair for this first one? Anyone know?
-3, 5.
Yeah, -3, -5. What's the next one?
-2, 0.
Yeah, okay. And then you just keep going. You just take this first one, -1, 3, 0, and 4, 1, and 3, 2, and 0, 3, and -5. Okay, so now we're going to graph those. So hopefully we can see it. I don't know if I zoom out all the way, what happens. So yeah, we can do it. So -3 and -5. So you're going to run to -3 and you're going to jump down to -5. Right? And then we're good here. Let's do -2 and 0. That's right here. -1 and +3. So you go to -1, you jump to 3. And then 0, 4. 1, 3. 2, 0. And 3, -5. Okay, so now that you've plotted your points, just connect those points. So we'll connect them. Okay, and then you can always just extend your graph out. Oops. So you'll see that it follows. If you plugged in those other values, they'll hit the graph. So anyway, This is our equation, and then go ahead and label it y equals 4 minus x squared. Let's remember, make sure that's what it was. Yes. So that's what this graph is. I would recommend like using like colored pencils or pens when you do your homework and stuff, because, well, not yet, but when we get into transformations, it'll be really helpful. So if you don't have any now, I would go ahead and just like maybe get some. It'll help you. You don't have to have them, but it's helpful. It helps you see the transformations when we get to there. So let's do another one. We're going to look at absolute value of x. So just remember that that's what those two lines mean. It just means absolute value of x. All this is saying is if I had -4 or 4, the absolute value is still 4. So absolute value of -4 is 4. Absolute value of 4 is 4. So that's all absolute value means. So let's take a look at some x's. Let's do -2, -1, 0, 1, 2. So what's the absolute value of -2?
2.
Exactly. Absolute value of -1, 1. Absolute value of 0?
0.
Yes. Absolute value of 1?
1.
And absolute value of 2?
2.
2. So what's your ordered pair?
-2, 2.
And so forth. -1, 1, 0, 0, 1, 1, 2, 2. Okay, so let's plot these points and see if I zoom out, if we can still see negative. I think we can. So -2 and 2. So we go to -2 and we jump down to -2. No, sorry, it was -2 and +2. And so that's another common thing we can look at. I already knew I made a mistake, because for absolute value, you shouldn't have anything in a negative, at least for this specific equation. So when I did that, I was like, oh wait, I think I did something wrong. So that's another hint for you guys. If you have something down here in this negative area, you probably did it wrong. So go ahead and double check your work. So -2, +2. So -2, jump to +2. -1 and 1, and 0 and 0, 1 and 1, and 2 and 2. So I'm going to zoom in now that I got that, and you'll just connect your points. And with that, you can go ahead and extend, and you'll see it follows suit. Absolute value of -3 is +3, -4 is 4. Okay, and we'll just label this y equals absolute value of x. Okay, so like I was saying, if you end up somewhere down here, you did something wrong, so double check your work. The only way you would have it is if I had a negative right here. And so let's look at that. If you had a negative right there, like we're getting a little bit ahead, but that's okay. If you had a negative, all that means is your values would end up being like this. And so we'll look more into that, transformations, when something like that happens. But for now, we're just worrying about what we have written. Okay. So something I had written down is, if you want to use a graphing calculator to check your work, you can read page 97 and 98 in your textbook. Don't depend on your calculator. You can use it to check like your work for graphing. But unfortunately, you're not allowed to use it on the test. The department doesn't allow it, so you don't be dependent on your calculator. But I don't mind y'all looking at it and checking. I think it's a useful tool, so that's okay. Just again, try to work these problems with the methods I teach you, and don't rely on your calculator to do all the work for you, because that will hurt you in the end. So intercepts, we're going to look at that. So an x-intercept means you're going to have some value in your x, and there's always going to be a 0 on y. And then for a y-intercept, that means you're going to have a 0 in your x and some number in y. So just remember that our ordered pairs look like this, x and y. So an x-intercept means you're going to have something on the x-axis, right? A y-intercept means you'll have something on the y-axis. Okay? So if I ask you what the x-intercept is, look on your x-axis. If I ask you for the y, look on your y-axis. So let's identify some of these intercepts. So let's go ahead and unmute ourselves. What is the x-intercept here?
4. Oh, -3. That's my bad.
No, you're fine. That's okay. -3 and 0. And then what about y?
0, 4.
Yes, 0, 4. Sorry, I said you were right, not close. Perfect. I was still thinking about x. Okay, that's good. What about here? What is our x-intercept?
2.
Mm-hmm. And do we have a y-intercept?
No.
No. So in this equation, this means well, I think it's x. I don't remember. I have to look. I think it's x equals 0, but I don't want to tell y'all wrong, so let's not worry about that for now. Right here, what is our x-intercept? Do we have one?
No.
No. And then y?
2.
2. Okay. And okay, yeah, it was. I remember now. I was just. It's x equals 2. Whenever you see this is the equation for this line. And so what that means is you go to your x-axis, and it goes all the way through 2. So if I had said x equals 3, it would look like this, right? So right here, what would the equation be? Is it going to be y or x?
Y equals 2.
Y equals 2, exactly. So you go to your y-axis and you go here. And so sometimes this confuses people, and that's why I wanted to talk about it, is because whenever you have, when you see y equals 2, for some reason our brains think like, oh, y, it needs to be vertical. So you might write y here, but what it's really saying is it goes through your y-axis and it goes through your x-axis. So just keep that in mind in case you're like me and it trips you up sometimes. So this one, what is our x and y intercept?
It's 0.
0, 0, 0, 0. What is 0, 0 called?
Origin.
Yes. Okay. And what about here? What are our x-intercepts? We have more than one here.
2 and 2.
2 and -2.
And our y?
4.
4. Okay. Cool. So this is we'll talk more about that actually next time. So anyway, next time we'll look at finding formulas for these graphs and graphing them just based on the formula, because you can do that without plotting, and it's actually a lot faster, and you'll have to do that. So we'll look at that a little more. But anyway, thanks for coming. I'm really sorry that I had to do a virtual lecture day. We'll go back to normal on Wednesday. Monday there's no class because it's Labor Day. So just work on your homework. If you have any issues or anything, just email me, and I have office hours today from 3 to 4:30 since I had to cancel yesterday. And then again, if you came in late or anything and you didn't hear my announcement at the beginning, if you missed the written assignment, I really just gave that to y'all in case we have to be posting on Blackboard more. Like if we end up having to post our tests and things, I just want y'all to get familiar with the platform. So again, before I leave here, I'm going to show y'all it one more time. And then if anyone needs to go, you can. But if you want to see this, you can look. So just again, you go to your courses. And this is where we're going to upload tests and things as well. So whenever I'll have something that says test, and you'll click it, and then you'll click the test one, or in this example, homework 1, and this is where you'll get your, this is where you'll put your submission. And if you took the photos on your phone or something, you'll have to just email yourself that photo, and you can download it to your computer and go from there. So anyway, if anyone has any more questions, you can do that. And if you didn't get it submitted in time, I reopened it and you can do it again. I just really want y'all to get practice and to memorize those cube roots and fourth roots.
Is there another homework assignment coming out today? Is that what you said?
There's one on Pearson. So I think I already posted it just because I was getting so many emails about people just wanting to do homework. So I went ahead and posted it, but I had put the due date way after. Oh, it's not let me sign in. Well, anyway, but yeah, it's on there. It's section 1.1, and so you'll do that one, and then I'll go ahead and I'll put the date for after, like, I don't know when it's due. I think it says the 6th, but I mean, y'all can work on it till Monday. I'll change it till the 7th, and then again, if y'all have questions, you can ask me. And then after this, homework's going to speed up a lot more. We haven't had any of these weeks because there's no homeworks to give you over chapter P that are already made. So just get ready, because there's going to be homework for every section now. Section 1, section 1.2, 3, and so forth.
Is homework underneath assignments?
No, homework's going to be on your Pearson account. This Blackboard assignment, that one, I just gave it to y'all for practice to learn how to upload things.
Yes, I'm in my math lab and it's not showing up.
It's not? Okay, hang on. Let me stop sharing real quick and let me get this verification and sign in.
Thank you for helping.
Yeah, of course. Okay, hang on. I have to wait. It's not letting me sign into Pearson for some reason. So let me see.
Are you on Safari?
No, oh, it's working now actually. I don't
it?
know, I'm not. It was Chrome, but here, I can share now.
It only works on Google for some reason.
Yeah, Safari, I don't know why. They don't like it, I guess. Where's share screen? Okay. So if you have multiple Pearson stuff, of course, you just select your class. And so your course home, I don't know if it looks the same as mine, but you just go to assignments, and here it is. It says section 1.1 homework, and you'll just click it. So do you not have that when you check?
I do not. Mine says your content has been opened in a new browser window, and there's no browser open.
Oh, I mean, we can stay in the Zoom with you and look at it. But
when that same thing happened to me, and like on like where my search bar is, there was like a little, it almost looked like a collection of pages. So like, but I don't know what kind of computer you have. I have a MacBook, so like right next to the search bar, it had like these it looked like 3 pages, and I just clicked on it and expanded a bunch of browsers, and it was in there somewhere.
Okay, so yeah, that might be happening. You might have like pop-ups blocked. So
yeah, that's what it kept saying for me too. It's like pop-ups or something like that.
So I think you go to probably. What are you using? Do you have what are you using to look at this right now? Just a PC or a Mac or?
MacBook.
A MacBook. So I don't know, because I don't use a MacBook. I have an iPad, and I know I've had trouble. So yeah, don't use Safari, and then try like Google Chrome, and then maybe try what he just said, because I'm not sure. It's probably you probably have pop-ups blocked or something.
Interesting. Okay.
And then I don't know. I don't know. You can share your screen with me if you want to, and we can look at it. But I don't know if you want to share it with everyone. We can do it.
I don't care. I'll do
it.
It
okay. Well, let me stop sharing and then change my settings so that you can share. Okay, you can share now if you'd like.
Okay.
We can leave if we have a class, right?
Oh yeah, class is over, so y'all can leave if you want. I had said that, but maybe you didn't hear.
Oh yeah, I didn't hear you. Thank you.
Okay. Yeah, of course you can leave.
Is the homework unlimited attempts?
I don't know. It didn't give me any kind of.
It says unlimited attempts on the questions, so that's why I'm curious.
Oh, okay. So you might run out of attempts, but then you can do similar question and rework it. That's probably what happens. Yeah, okay. I don't have control over that, unfortunately. So yeah, that's probably what goes on. So if you get it wrong, I bet you can do similar question and get full credit. That's how it used to be for me, at least.
Okay, can you see my screen?
Yeah, I can see it. So go ahead and don't use Safari.
Use Safari.
See, like what worked for me was like, see, like right there next to your search bar, right next to the refresh button, those little pages things right there.
Oh.
Yeah, I just clicked all that. See, it opens all those little tabs, and then it's in there, like it's in one of those.
Oh, there it is. Okay.
Thank you, whoever was helping. Thanks so much.
Yeah, you're welcome.
Thank you so much.
You're welcome. Does anyone else have any more questions? No, I think a lot of people.
Did we talk to you about the tutoring session with Soto?
Soto? I don't
You
know.
that's not with you, right? Because
No.
that the girl that's in the class that's like
Oh,
there to
you mean
help us,
Erica?
right?
Yeah, yeah.
Erica,
I just
yes.
didn't know her last name. Erica. Yes. She has SI sessions. I think how those SI sessions are working because there's just a capacity policy that so you have to make a reservation with SI.
They're
So
face to face, right? Because I've already made reservations and I was just making sure.
Okay, so then I think they send you out the room number, and I think those are Tuesday, Thursday, right?
Yeah, you can choose any days, but yeah,
Okay.
Tuesdays and Thursdays.
Okay, yeah. So yeah, you'll just have to talk to her about it, and then she'll get stuff from me too, like reviews and things, and help you guys with. So those SI sessions, I'm sure, will be really helpful. Yeah.
Okay, thank you.
You're welcome. Anyone else have any more questions? No? Okay. All right. See you guys.